In this video, I'm going to show you a very rich piece of gold ore that came out of a very old Spanish mine in the Uinta Mountains of northeastern Utah. And we'll talk a little bit about the unique geology of where this mine is located. And we'll talk about some other stuff that's related to the mine. This right here, this is the piece of ore. And I'm going to rotate this all around for you. And we'll talk about the rock more in depth here in a little bit. But as you can see, there's a lot of native copper, especially on the side of the rock. All of this grain and blue, this is all oxide from the copper, but very beautiful. And then as you rotate it to the top, this is where your gold is. And all across the top here is just a mixture of gold and copper, but a very beautiful piece, especially under a loop. But this is what the Spaniards wanted. This is what they came for. Man, it's starting to get hot. We got some old mines. We got 1, 2, 3, 4, 5. Pretty cool. I have no idea what they were mining. But what we're going to do now is, this is just a simple continuity test. And I'm just going to do this to show you that there's no sulfides in the minerals, you know, like chalcopyrite or bornite or something like that. And of course, your sulfide minerals contain sulfur, which acts as an insulator. And so on this test, we're going to basically test for continuity, for conductivity. We're just going to pass an electron through the batteries, through the leads, through the different metal, and back to the device. So don't worry about the numbers on the screen. Just listen for a beep. So hear that beep. And when you hear the beep, that means you're passing the electron. So I can put the leads anywhere on here. Doesn't matter where. And we got good continuity across everything. But these are real helpful tests when you're testing for copper, gold, or silver. I came over in the shade to get out of the sun, and this way all the copper loses its luster and you can more easily distinguish between the gold and the copper. And this way you can kind of get an idea of how much gold is actually in here. And as you can see, there's a lot. And of course, the gold is the yellow stuff that maintained its brightness and luster even here in the shade. But very beautiful. So we know the Spaniards were interested in the gold. Everybody knows that. But what about the copper? Were they interested in this copper, or did they view it as just a byproduct, a waste? And the answer is they were most definitely interested in the copper, and I'll explain why. I found me a nice little cave to take a break in and cool off. Just a little word of advice: when you find little caves like this, before you get too comfy, make sure you look around for rattlesnakes. But so copper. So copper's always had value in every advanced civilization, going all the way back to the Copper Age. It's been used to make many different things. But during this time period, when the Spaniards would have been mining in the Uinta Mountains, and I believe that's the late 1700s to early 1800s, and that's just my opinion. Some people think it's earlier than that. But during this particular time period, over in Europe, and it all started in Great Britain, you had a lot of very intelligent entrepreneurs and inventors that were inventing new devices like your power loom, the sewing machine, the steam engine, many others that were revolutionizing industry. These were mechanizing manufacturing. And this is what led to the Industrial Revolution. And the Industrial Revolution spread all around Europe and from there to the European colonies here in the New World. And the Industrial Revolution required a lot of copper. It was very copper intensive. And back then, Great Britain had an abundance of coal and copper, and the smelters needed to fuel the Industrial Revolution. And it's estimated at that time that Britain was responsible for about 50% of the world's total copper output. But like anything, that has limitations. And so what kind of like tipped the scale was during this time period, the Royal Navy, and the Royal Navy at that time was the largest navy in the world. And they decided they were going to start copper sheathing the hulls of all of their ships. And this would serve three purposes. Mainly, it would make the ships stronger. It would make the ships faster because it would help reduce barnacles and marine deposits from building up on the hull of the ship. And it would also help prevent shipworm. And shipworm are these nasty critters that look like worms. I think they're technically clams, but they would eat through the wood in the ships. Think of them as like termites of the ocean. And it's estimated that Britain during that time period, they had about 429 vessels that they applied this copper sheathing to. And each vessel on average took about 15 tons of copper. And to put that in perspective, that's like the equivalent of building over 200 Statue of Liberties. So that put quite a stress on the entire copper industry. And the price of copper just shot through the roof, and prices tripled during that time period. And so Spain, like every other advanced economy during that time, relied on this copper. And so it put Spain in a bit of a crisis mode regarding their economy. Think about it, they needed copper to alloy with other metals. They needed copper for their coinage. They needed copper for their sugar plantations, to process the sugar. Now they needed copper in shipbuilding and a whole list of things that they needed copper for. So during that time period, the Spanish authorities were actively encouraging people, especially here in the New World, to go out and find new deposits of copper that could be exploited. And so these miners during that time period would have most definitely had a very, very strong market for the copper. All right, that brings us to the most important thing, the rock. So the most valuable thing here is not the gold, it's not the copper, it's this, the rock, because that's going to tell us where everything else came from. And this type of rock, this is called basalt. And you can pull up all of your geological maps for the entire Uinta Mountains, and you won't find this anywhere. This area we're going to talk about, where you have these basalt outcroppings, is undocumented. And basalt is a very fascinating rock. It's probably one of my favorite rocks. And it's an igneous rock, and it forms from lava that comes up either at or near the surface of the earth and cools very rapidly. And so basalt, when you look at like the moon at night and you see all of those black pieces of the moon, the black surface, that's all this stuff. It's basalt. The surface of the planet Mars consists primarily of basalt. Your oceanic crust consists primarily of basalt. And because this is lava and the way it forms, you can get some really neat types of basalt. You can have columnar basalt, which forms these very beautiful pillars. You have pillow basalt, where the lavas came into contact with water. You can get lava tubes with these beautiful natural caves. And so this particular piece of basalt, you'll notice hopefully the camera will pick it up. I'm trying not to hold the rock and shake it around and get you all sick, but you can see those holes right there. So how they form is as the lava is coming up to the surface of the earth, right? And you have this gas that's trapped in the lava. And as the lava is coming up, this gas will form these bubbles, you know, as it leaves the lava. And what happens though is if the lava cools too quickly, this gas will get trapped in the lava. And that's what creates all these cavities, these pockets. And these are called vesicles. And so normally you'd classify this type of basalt as vesicular basalt. But what happened in this case is you have these secondary minerals that came in and filled in many of those vesicles. You obviously have your gold and copper, but there's also a white mineral in here and there's a red mineral in here. I'm not really sure what it is, but if I had to guess, I'd probably say agate or something like that. And so this type of basalt is classified as amygdaloidal basalt. And now I'll tell you a little bit about the area in the Uinta Mountains where you can find this basalt. In the Uinta Mountains, there's certain areas you can go to where you can still find old Spanish smelters. A lot of them are in very poor shape because over the years you've had careless people go in there just tearing them apart, looking for scraps of gold and silver, which is a real shame. I'm not going to show an image of this particular smelter that we're going to talk about because I don't want to give away the location. But what I'll do is, for those of you not familiar with what Spanish smelters look like, I'll find a picture on the internet, hopefully one that's very intact, and then that way you can get a good visual of what I'm talking about. But these old smelters, just think of, they're like primitive ovens made out of rock and clay that were used to process, to smelt the ore. And how they worked was you'd start with your ore and you'd crush your ore and then you'd remove the metal and then you would place this ore in a crucible and you would put the crucible in the furnace and then you'd pack charcoal all the way around it, on top of it, everywhere you could put charcoal. And the charcoal served two purposes. First, it was your source of heat. It was your source of fuel. But second, it would act as a reducing agent, and it would help reduce the oxygen in the metal, helping to create a more pure metal. And then you'd have like a bellow type system to force oxygen into the furnace to bring everything up to these high temperatures. And so as the metals in there melting, what happens is you get these different oxides and different materials that kind of form around the metal. And this is called slag. And slag is just a natural byproduct of the smelting process. And so then they would remove the slag and they would dip it in water to hurry and cool it off. And this is why all of your smelters, you'll notice they're always by a source of water, usually a small stream. And then once they cooled off the slag, then they would take hammers and they would remove the slag from the metal. And then they would take the pieces of metal, put it back into a crucible, put the crucible into the oven, melt it, and then at that point, they were able to pour their bars. And another thing you'll notice about the smelters in the Uinta Mountains is not always, but more often than not, they're down at a lower elevation. So the smelter will be low and your mine will be up high. And there's a very practical reason for this. So as you go up in elevation, you go up in altitude, you have a loss of atmospheric pressure. So you have a decrease in your oxygen density. And this is why people, especially people who come from lower elevation states, when they go into areas like the high Uintas, sometimes they'll suffer from altitude sickness. And, they'll get sick or delusional. And sometimes it's pretty severe, and they'll have to be taken to the hospital but it's because their body's not getting enough oxygen because they're at this high elevation. And the exact opposite occurs when you go down in elevation, down in altitude. Your oxygen density increases. The Spaniards needed that excess oxygen to be able to bring their furnaces up to the desired temperature and maintain it. Keep in mind, the melting point for gold, for example, is around 1,948 degrees. In the Uinta Mountains, there's a particular smelter, and if you know where to look, you can still find the old trail near the smelter that the miners were using to come down from the mine to the smelter. And keep in mind, this trail is very old, so you can follow it and then you'll lose it, and then you'll find it again and you can follow it further, and then you'll lose it, and then you'll find it again and you can follow it a bit further, and then you'll lose it. And there just comes a point in time where you can't follow it any further. It's just gone for good. But by that point, you got a pretty good idea of right where the trail is headed to, where the mine is located. And so what I did is I went to a different area where I could hike down into this particular area to search for the mine. And in this area is where you have these outcroppings of the basalt. Now, I've only seen one. There's more, but I've only seen the one, so I can only speak for the outcropping that I've seen with my own eyes. And what it is, this one is about 7 feet, 6 or 7 feet in diameter, comes out of the ground maybe about 2.5 feet. And what I think it is you're seeing the tip of like a cylindrical basaltic dike. And I'll throw up an image so you can kind of get an idea of what I'm talking about. But I think that's what it is, and you can only see the very tip of this dike poking out of the ground. And I don't know how something like that would form. My theory has always been, like in this area, you have some ancient geysers. And we're not talking about like a super volcano like Yellowstone or anything like that. Just an area where a very long time ago you would have had some geysers. And then you had seismic activity. The magma came up very quickly, and the lava flowed through these vents and, solidified, hardened, and plugged off the vents, turning into the basalt. And I think that's how you got these basaltic dikes that come out of the ground. I've searched for the mine 2 different times in this area, and I could not find it. I got a friend, somebody who I'm very close with, and he watches these videos, so hello. He doesn't do this anymore, but he's also been in this area, found the basalt rock while searching for the mine. He wasn't able to find the mine either. Now, keep in mind, this area I'm talking about, this is very forested. You're talking about old growth forest where you have a lot of big trees, a lot of little trees, a lot of underbrush. You could be 10 or 15 feet away from the mine, little mine opening, and not even know it's there. This isn't like searching for a mine out in the desert or something like that. But there's one guy who did find the mine, and he's passed away now. That's the only reason I even feel comfortable talking about this. But he found it the same way. He followed the trail, lost the trail, but he knew right where the trail was headed. He went into the area, and he actually found the old mine. According to him, the mine is collapsed. It's sealed off. There's no way you can enter into the mine. So what he does, he took a metal detector in there and went all around the old mine site, looking for like silver, gold, artifacts, and things like that. And he found these 2 pieces of ore, the piece that I showed you, and then he had another piece that was about maybe like the size of a baseball, maybe a little bit bigger. Same thing, just full of copper and gold. And so probably what happened is that was the ore pile where the Spaniards were stacking the ore until they had enough ore to take down to the smelter to process. And these two pieces, little bugs flying on me, these two pieces were probably like at the bottom of that ore pile. So they had all that weight pushing down on them, and they got pushed into that soft mountain soil. And so the Spaniards didn't know they were there, and that's how they got left behind. That's probably how all of that came to be. This area, I would love to know how this stuff could form. But the only way we would ever know that for certain is you'd have to have geologists go into that area and study the rock and figure out how all that formed geologically. Someday, not now, but someday when I'm all done with all this, I probably am going to take some of the forestry geologists up there, show it to them, and then that way, they can document this site, add it to the maps, and then other people can enjoy it. People who like rock hounding and stuff like that, they'll be able to hike in there, and look at some volcanic rock. As far as the mine goes, whether there's anything left in it or not, I know of 3 old Spanish mines in the Uinta Mountains that attempts have been made to reopen. All 3 turned out to be failures. The Spaniards have pretty much cleaned them out. That's probably the case with this mine, but you never know.